Okay, good day everyone. This is JP Morales and we continue our discussion on coding theory. And in this video, we discuss some codes with error detection and error correction capabilities. The first code that we will discuss is called parity check codes. For parity check codes, a bit string is said to have an odd parity or even parity depending on the number of ones in the string. In short, it is an odd parity if there are an odd number of ones, and it is of even parity if there are even number of ones. For example, the first bit string is of odd parity, whereas the second bit string is of even parity. The simplest form of error detection is parity, where a single bit is appended to a bit string. The idea is to have a code with only one parity. So in parity check codes, the sender and the receiver agreed on using a single parity. Say for example, even. So to produce an even parity check code word, we append one bit on each of our code words so that all of our code words will be of even parity. So once we have produced a code with even parity and a receiver received a message with odd parity, then definitely the receiver knows that there is an error. That is because the receiver and the sender agreed on using only even parity. So to illustrate this, let's try an example. So include a parity check digit to make an even parity code. Suppose that our valid messages are yes and no with this initial code, 000 and 111. Now we append one bit in order to produce an even parity code. So what bit should we append so that we produce a code with only even parity? So for yes, we append 0. For no, we append 1. So in this case, the sender and the receiver only agreed on using even parity. Now suppose the intended message is yes. It is converted to string of zeros for 000 for yes. It went through noisy channel and it got altered. So notice that the receiver got something of odd parity, when in fact the sender and the receiver agreed on using only even parity. So definitely there is an error. But in this case, the receiver knows that this one is closer to 0000 than to 1111. So the receiver will likely decode 0100 as a yes. Now let's try another example. Suppose that the sender and the receiver agreed on using only even parity. So what bit should be appended on each of these code words in order to have even parity? For the first one, we append 0. For the second one, we append 1. And the third one, we append 1. In this case, the sender and the receiver are only using even parity. Let's try another example. Suppose that the sender and the receiver agreed on using only odd parity. Here are the initial code words. So what bits should we append to here so that we produce a code with odd parity? So for the first one, we append 0. For the second one, we append 1. And for the third one, we append 0. Okay. So we have seen that parity check codes have error detection capabilities. But does parity check code have error correction capabilities? Let's take a look at this illustration. Suppose that the sender and the receiver agreed on using only even parity. These are the set of valid messages. You have yes, no, and maybe. Now, because they want even parity, they have to append one bit in order to have only even parity code words. So to do so, we will get 0101 for yes, 1010 for no, and 1100 for maybe. So this is our source coding now, after doing the appending of one bit. Now suppose that the binary word received is 1110. Now we know that definitely the receiver knows that there is an error because the receiver received something of odd parity when in fact the receiver and the sender agreed on using only even parity. So definitely there is an error and we are able to detect that error. But can we correct this error in this case? Please comment below for your answers. And based on your answer, um, do you think parity check codes have error correction capability?